Okay, so this is the C part of the question. So you're told that f of x, C part 1 we're told f of x is equal to 1 all over x squared minus 6x plus a, and we're told that we're going to be working with a equals to 13 for parts 1 and 2 anyway. So what we'll do is we're trying to show that f of x is greater than 0. So we'll say 1 over x squared minus 6x, and we'll put in our 13, and we want to show that that's greater than 0. So 1 over, it's underneath the line, we're going to use a process called completing the square. So x squared minus 6x, you break the 13 up into a number that is a perfect square and its remainder. This instance 9 plus 4. 1 all over. If you have a look at this portion here, you'll see that it's x minus 3 all squared plus 4. 1 is always positive. What's beneath the line now we know is always positive. And that's part 1 done. Part 2, again, you're going to be working with a is 13, and this time you're trying to show that f of x is less than 1. So we'll start using a similar procedure. So 1 all over, so x squared minus 6x plus 13. I'm going to show it's less than 1. Okay. What you need to do here is, I think, you need to have a little bit of an understanding about what happens with reciprocal numbers and things like that. So what I want you to consider is the number 2 greater than 1? And of course it is. So if a number is greater than 1, well, that implies that its reciprocal, or in other words 1 over that number, will be less than 1. If you pick any number, we'll pick 10. 10 is greater than 1. 1 over 10 will be less than 1. Now if you take that piece of information and you work backwards, so it works forwards and it works backwards, and you apply it to the situation that we're looking at here. If we know that 1 all over x squared minus 6x plus 13, if we know that that's less than 1, well, this in turn implies that x squared minus 6x plus 13 is greater than 1. And if we can show this to be true, well, then we can infer backwards that our original statement was correct. So x squared minus 6x plus 13, but we know that we know that's 9 plus 4, of course, greater than 1. So we'll have x minus 3 all squared. Bring this 4 across, minus 3. So a number that's positive, is that always greater than minus 3? Yes, it is, which implies all of our statements are true all the way back up to our original. So how would you finish that off if you were just going to write a sentence or something like that for your examiner? So you'd show the workings that I've just shown. So just to finish it off, you might say, as x squared minus 6x plus 13 is greater than 1, then 1 over x squared minus 6x plus 13 is less than 1. In other words, f of x is less than 1, and that's what you were asked to show. Okay, so part 3 of the question. You're asked, find a range of values of a. So you want to find the range of values of a that will satisfy the condition f of x to be less than 0 greater than 0 and less than 1. So in order to do this, we're going to look at two separate scenarios. We're going to first of all look at the scenario where f of x is greater than 0. Of course, we're looking for a value of a, so we won't be putting in 13. So we'll have now notice that I'm not using 1 over for the f of x. Remember that for f of x to be greater than 0, both numerator and denominator have to be positive. So in this instance, I'm just going to look at the denominator, and I know the denominator has to be positive. So again, a little bit of trickery. I'd like a plus 9 in there, but if I put in a plus 9, I have to subtract 9. And the reason I want a plus 9 in there is because it allows me to complete the square again, like I've seen earlier on. So x minus 3 all squared, which is something positive, plus a minus 9. So we know that bit is going to be positive. So in order to examine what values of a we need to sort of say to ourselves, what value of a will ensure that a minus 9 is always positive. So we'll take a minus 9. Where is a minus 9 greater than 0? A must be greater than 9. So when a is greater than 9, f of x is greater than 0. The second thing that we need to take a look at then would be f of x less than 1. So 1 over x squared minus 6x plus a greater than 1. We're going to use our we'll change what's underneath the line first. So that'll be x minus 3 all squared plus a minus 9 from what we've seen earlier on. And what we're going to do is we're going to use that reciprocal fact that was explained earlier on. So we know that x minus 3 all squared greater than 1. And what we're going to do here is we're going to drop the brackets there as well, just on the second part. So x minus 3 all squared plus a minus 9. There's no harm in dropping those brackets, and at the same time we're going to bring that 1 across. So now we're dealing with something that we need to show is greater than 0. Of course we know this bit is positive, so we're doing the exact same thing again. We need this bit to be positive for the whole thing to be greater than 0. So we're asking ourselves, what value of a, what value must a be, or what values of a can a be, so as that a minus 10. So the values there would be a greater than 10. Now if you have a look at that, there are essentially two answers to the question. But what you asked for is the values of a, essentially that will satisfy both conditions. And a greater than, anything greater than 9, well of course there's 9.1, 9.2, etc. and a greater than 10. The only answer that will satisfy both conditions, both original conditions, and the original conditions are back here, is a greater than 10. Because, just so as that you know why, if for example a was 9.5, it would satisfy the condition over here. In other words, it would satisfy the condition f of x greater than 0, but it would not satisfy our second part of that condition, f of x less than 1. And that's why this is the only answer that we'll use.